$500,000, and it costs the company $45 to produce each radio.
How much again?
$45 for each radio.
Yes. So if just one, allow me to stop you for a second. It's a perfect problem. Thank you so much for bringing that. So if it costs us $45 per radio, then if we manufacture X, it will cost us 45 times the number of radios we produce. Is that okay? So this is fixed cost. And this is what is called variable cost. Why is it variable? It depends on X. If I manufacture only one, I'll pay 45. If I manufacture two, I'll pay 90. If I manufacture three, if I manufacture four, so it's variable cost. Very good. So please continue.
It says each radio will sell for $65.
Right, so then the revenue is 65 times X. Revenue. The revenue, of course, depends on how many units we sell. So if we sell one, we get 65. If we sell two, we get 65 times 2. If we sell three, and so on and so forth. Is that clear so far? So every time we read a problem, always try to take notes from the problem and then go back and make sure that you understood everything correctly and everything is in the right place. Yes, I'm ready.
And then the company's cost and revenue are modeled by the following function.
Yes.
Where X represents the number of radios produced and sold.
Okay.
Find the interpreter, and this is
find the.
What's that?
Find the profit.
Interpret. Oh, I mean, it's giving me 3, whatever. But,
okay.
And so in parentheses, it's R minus C.
Okay, so this is the profit, which is revenue minus the cost. These are both functions of the number of radios we produce and sell. So the profit is money coming in, revenue, minus the cost for per each radio. Yeah, I'm ready.
But it's like in parentheses R minus C, and then parentheses again is
right.
12,500.
Right. So they're really asking us to find R of R minus C of X, but basically for R minus C of 5,000 units. That's what they're asking us to do. Perfect. Perfect question. Okay, so this is a function determined, it's a profit function, and it's determined by subtracting the total cost from the revenue. Because we know what this means. It's this, right? So by definition, R minus C of X is R of X minus C of X. If I put here 5,000, that's all I have. R of 5,000 minus C of 5,000. We already created the functions before we even looked at the question. So then R minus C of 5,000 will simply be R of 5,000 minus C of 5,000.
Where are you getting 5,000?
Oh, I thought you said 5,000.
Oh, no. 500,000. No, 12,500.
Oh, okay. So 12,500.
And that's just one. There's 3 different setups.
Yeah, well, once you understand this one, you should have no difficulty with the other one, but I'm more than happy to show the other one.
Yeah. I just want to make sure.
Oh, yeah, of course. So I thought you said 5,000. Sorry. And you understand here you're just plugging them in, right? You have the functions, right? So the revenue of 12,500 will be 65 times 12,500 minus the cost, which is 55 times 12,500.
You also got to subtract the fixed cost, though, because I think that's what the question was asking.
Does it? Okay. Oh, so we have to say the total cost function. Yes, you're right. It's 45 times X plus 500,000. Yes. So that's the total cost function. So I'm going to just call this just variable cost. Thank you. Absolutely. So the variable cost, the total cost function is indeed variable cost plus fixed cost. So this is our cost. So I'm going to continue from here. The revenue is 65 times 12,500 minus, in parentheses, I think it's better not to forget to distribute later. So 45 times 12,500 and plus 500,000. Be careful, this has to be in parentheses. Because you will have to, I'm sorry?
It's going to be minus 5.
It has to be. I have to subtract both. That's why I put it in parentheses.
Oh.
Absolutely. So it's this times this and minus 1 times that.
You're making it confusing. The way you're doing that, I guess, I don't know.
So do you understand that this is the total cost?
I understand it, but the way you're doing it is making me confused. Like, I got it the way I got it, but the way you're doing it up here is not. It's not right.
Okay, so R minus C of 12,500 is the revenue minus the cost.
I get it.
Okay, so I copied the revenue
I get it.
and I wrote minus the total cost function, which is this. So which is 45 times 12,500 and plus 500,000. And since I'm subtracting it, this is what we learned last time, right? That if I have f plus g of x, this is f of x plus g of x. But if I have f minus g of x, and it happens that this function has two terms. So if I have f minus g of x, I have f of x minus g of x. And this is my minus c of x that has two terms. And that's the reason why I have to distribute -1. I'm not saying that this is the only method. I'm not saying that you have to use this one, but this is the correct method for f minus g. So then I will just rewrite. But normally what I would do, I would say 65 minus 45, which is 20. So this is 20 times 12,500 and minus 500,000. And we get the answer. It doesn't matter how you get to the solution. I'm fine. If you want to write it in 2 steps, you can write it in 2 steps. That's true too. That's correct too. But that's how we write the function, adding and subtracting functions. Okay, so if everything is okay, I got a loss. Am I correct with all my numbers? I got a loss, because it's minus, of $250,000. Okay, let's see the next question. What was the second one? I thought there was a
Oh,
different.
you wanted to keep doing the rest of them?
Unless you
I
say.
mean, no, I got it, but I mean, if everybody did it the first time, you want to do it the second time, that's fine.
Is there anything else that you want me to show here? Anything?
I got it the first time, so I could do it every time.
So, you're just given different values.
Yeah, like
of
so
X.
12,500,
Oh, okay.
The next one's 25,000.
Okay.
And so on.
So I'm assuming that you're gonna probably come up with first a loss. So you're gonna tell the manufacturer, if you only manufacture 12,500, and you assuming you're not putting them on the shelf, right? You're selling them. Then you're gonna have your production unit is working at a loss of $250,000. Again, I don't know on what time frame. It could be per year. I don't know that. They didn't say. Then probably a different number will probably give you a break-even point, which means you're not making money, but at least you're not losing money. Revenue equals the cost. And I'm assuming that after a certain value, then the revenue will be much bigger than the cost, and you're working at the profit.
Well, yeah, just ask what is the meaning of this, and it just gives you options of different.
Well, can you read the options for everyone? So.
Do you want me to read all of them, or just read the one that's the right answer?
So just to read any, so we know what.
So if the company sells 12,500 radios in 1 year, its net loss is 250.
Right. Okay. So that's
it.
clear. Okay.
And the other ones are or profit 250,000.
Right. So normally it's a loss, a break-even point in which revenue equals the cost, and also profit. Very good question. Thank you for bringing that. I hope everyone is there at the same type of problem. Good. Anything else for me? Anything
Yeah.
else? Yes, please.
So f of x equals
Yes.
x squared plus 4, and g of x equals x squared minus 1.
X squared minus
1.
1. Excellent.
And then f comma g of x.
F of g of x. You want f comp g of x? Is that what you said? Okay, yes. So f comp g of x is the same with f of g of x. Agreed? Okay, so my first step is I have to replace g of x. It's the inner function. I have to work with the inner function first. And then I look at f. F says whatever squared plus 4. Whatever squared plus 4. So let's see if we understand this step, because the rest will not be difficult. Do we understand this step? Yes. How many terms do I get when I square x squared minus 1? Thank you. How many? How many? Excellent. So x to the 4th minus 2x squared plus 1 and plus 4. So this is x to the 4th minus 2x squared plus 5. So this is a totally new function, and it was determined using the function composition f comp g, where g is the inner function and f is the outer. Very good question. Anything else? Yes, please.
Also, not a question, but I just want to make sure, because you told me, I don't want everyone to know, that we have to write out the
Yes, so
on the test.
yes, please do. Like I write it here. So it's f comma g.
Yeah.
I thought there was a starting point in the problem. So, but I misunderstood. So we have to write this first. Then we have to write this. Then this is the third step, and then we continue to simplify it. Please do. It's easier for you too, so you don't make an error. Will I really deduct points if you just write that? No, I will not. But you need to understand the connection between these two, so you don't make an error. Okay, anything else? Very good questions. Is there anything else that you worked on? Anything else that you would like to see? Anything? Okay, so you can always stop me. Remember, I'll go back to anything. Let's now look at the following. Can anyone give us a linear function?
Is it still 2.7?
Yes, yes, thank you.
2x plus 3?
Very good. Excellent. Is this a linear function? Everyone agrees? Yes? Okay. I don't remember if we looked at a few graphs before we talk about this function, but let's look at a few graphs. You know all of them. How come? You'll see. This one, you know the shape. We're going to talk about it a lot in chapter 3. So just for now, copy that graph. My question is, this is a linear function. Which of these 4 graphs is a linear, represents a linear function? 1, 2, 3, 4. 2. We all agree? Here's my question. Is this a one-to-one function? How do we know? Remember, to each y, only one x. So by the horizontal line test now, excellent, only one x. For this y, only one x. For this y, only one x. So this is one-to-one. Does it have an inverse function then? The linear function, does it have an inverse function? Yes, because it is one-to-one. Excellent. What about this function? What function is this? We've seen it. We worked with it. What type? Quadratic. Excellent. Is it one-to-one? No. Not one-to-one. What if I do this? Because we will. What if I do this? Meaning that is the quadratic function defined only from 0 to infinity. Is that one-to-one now? Yeah, so the point I'm making is that from a function that is not one-to-one, I can chop it up, and that piece can be one-to-one. So I can do that. Okay, good. What function is this? Yes, awesome. So this is x squared. This is the cube root. Is the cube root 1 to 1? Yes, it is 1 to 1. It will have an inverse function. What about this one that looks like x cubed? Is this one 1 to 1? No. Here's why. For one y value, I found not 1, not 2, but 3 different x values. So this cannot be 1 to 1. Okay. So now knowing that the linear function is 1 to 1, we are asked to find its inverse because it has an inverse. So find f inverse for the function you just gave me. That's number 1. Number 2, graph both on the same coordinate system. After we find the inverse function. Again, it's a 4-step procedure like the completing the square. Just the fact that they're not the same, but the fact that there are 4 steps to, that we need to go through. So 4 steps. Thank you. I don't want to sneeze. I never want to sneeze. Sorry. Okay, so 4 steps. Number 1, replace f of x with y. Do you allow me to do that? Would you agree? Yes. F of x and y are the same. Agreed? So then I replace and I write y equals 2x plus 3. In step 2, I interchange x and y. Meaning, I want to write x here, and I want to write where I see y, I replace by x. Where I see x, I replace by y. And now we have to discuss this. Because we've never done this. Interchanging or changing x into y and y into x at the same time. Why? Why am I doing that? And who allows me to? Or am I allowed to do that? So, if you remember last time we had the connection between the function and its inverse. And we said the function will take 1 to 2, for example. The inverse function will take 2 back to 1. What does this mean? It means that now this value, y equals 2 for function f, becomes x equals 2 for function f inverse. So this number is the y value of f, but it's the x value for f inverse. 1 corresponds to 2, and now 2 corresponds to 1. So that's the reason why I'm allowed to interchange just this time, one time, replace x by y and y by x. Why? One more time. Because now 2, f inverse is applied to 2, so therefore 2 becomes x value. That was initially the y value for f. In step 3, we solve for y. And that is not difficult. We know we've done this many times. So I subtract 3 and divide by 2. So this is x minus 3 divided by 2. A linear equation. We move 3. It becomes negative and divide everything by 2. And this is it. In step 4, we are just changing the notation again. Not interchanging anything. We are just denoting replacing y by f inverse. And that's it. So 4-step procedure. Number 1, we replace f of x by y. Number 2, we interchange those x and y, swap them. Why? Because y for f becomes x for f inverse. So just one time we are allowed to do that. and that's the reason why. And then we solve for y, and then we replace y by f inverse. In step number 2, we're asked to graph both. So I'm going to start with f of x, which is 2x plus 3. Since it's a linear function, how many points we need to plot? Yes. So when x is 0, please give me the y value, and later on when y is 0, please give me the x value. When x is 0, how much is y? Very good. And what is the ordered pair? 0. Very good. And now when y is 0, I have 0 equals 2x plus 3, or negative 3 equals 2x, or x equals negative 3 over 2. And what is the ordered pair right now? Excellent. So I have the necessary points to graph the function. Perfect. So I'm going to plot 0, 3. I'm going to plot negative 3/2, which is negative 1.5. I'm going to connect and extend the line. And if you remember, I said, please don't forget to write f of x equals 2x plus 3 anywhere you want. On the graph, below the graph, left, right, doesn't matter. Okay. Every time we graph the function and its inverse on the same coordinate system, please remember we have to graph this line, and everyone knows what this line represents. We graphed it. It's the first function in the list of transformations. What is it? Thank you very much. Good. So now I should go back to the inverse function and create 2 points like I did for the function and plot them so I can graph the inverse. I refuse to do that. And you'll tell me why I refuse to do that, and you will give me 2 ordered pairs to graph the inverse function with no effort, with no calculations required. And I'm ready when you are.
3, 0.
Careful. Oh, yes, 0, 3, 3, 0. Very good. So this is the opposite, the symmetric point with respect to y equals x. Excellent. And I need one more. However, I really don't, because if the function crosses the y equals x at this point, you can reverse, because all points on this line have the same x and the same y. If you reverse it, you'll still get the same point. So I really don't care for the other point, but of course the other point must be the symmetric of this one. With no effort whatsoever. I did not need to calculate anything. So here is a note that we have to write. Note: the graphs of f of x and f inverse are, with respect to the line y equals x. I'm missing a word. I need help with one word. Very good. Excellent. They are symmetric. Here's why. They overlap. This overlaps with that, this with that. If I fold the graph with respect to y equals x, it's an absolute copy, reverse everything on the other side of y equals x. This will always be the case when we graph the function and its inverse on the same coordinate system, always. If the graph does not cross y equals x, the inverse will not cross y equals x. But if it does cross y equals x, the inverse function will cross at the very same point. Mandatory.
Wait, so F negative 1 R what?
F inverse. It's not f to negative 1.
Okay, F inverse. What's that number on?
Say it again.
Okay, in your note.
I said the graphs of f and f inverse are symmetric with respect to the line y equals x.
Okay, so wait, after symmetric, what is that?
With respect to. We wrote that many times in transformations. I forgot to tell you again. With respect to the line y equals x. Any questions here? Any questions? Okay, I'd like to look at graph on page 322, just to cement our information. Okay. I need a pencil. Okay, is 37 a function that is one-to-one by the horizontal line test is one-to-one? Perfect. Will it have an inverse? It will have an inverse because it's one-to-one. Perfect. Okay, so then I'm asked to graph the inverse function. I will definitely have to graph y equals x. That's mandatory always. And now please give me two ordered pairs that I can plot to graph the inverse. I don't know anything about it. I don't know what it is. You will in chapter 4. You will know what this function is. So you said what?
2 negative 4.
So this is 2 comma 4.
I know, I said 2 negative.
We are reversing. We're not changing the signs. So let me say this one more time.
Oh,
2
go back.
corresponds to 4.
I didn't mean to say that.
4 corresponds to 2.
What page is this? I didn't read it from.
322. So can anyone give us two ordered pairs?
One zero.
Very good. So this is 0, 1. We want 1, 0. Excellent. Exactly symmetric with y respect to y equals x. Next. So we have 1 comma 2. So then 2 comma 1. Exactly symmetric here. This distance, the distance between this point and y equals x is identical with distance from this point and the y equals x. Can I get one more? I cannot 3, 3 because the graph of this does not go through 3, 3. 3, 3 is here. So the graph of the original function does not go through 3, 3. So which one? 4, 2, indeed. So the symmetric of this. So 4 comma 2. Excellent. So here's the graph. This is the graph. Oops, sorry. This is the graph of the inverse function. We're going to graph it in chapter 4. Is it clear how we graph the inverse function given the function? Yes? Is it clear why we reverse the coordinates? Yes? Okay, perfect. Thank you. Oh, I need that here. So, what else is here? Let's look at a word problem. And also I would like to, I worked on these problems the other day with the other class, so I'm erasing for you. And also this now. Okay. Good. So here's a problem. I don't think we did this problem, but if we did, let me know. Did we look at this problem, 67? I don't remember.
On the next page?
It's on page 323.
No.
Perfect, let's work on it. The graph represents the probability, the percentage, right? Between 0 and 1, or percentage, probability that two people share the same birthday. We're not talking about year, we're only talking about day and month. Okay? So, in the same room, sharing a birthday is a function of the number of people in the room. So let's say we are here, let's say 20 people. What is the probability that two of us share the same birthday? Let's say May the 5th. Okay? So if we have 20 people in the room, according to the graph, what is the probability that two of us have the same birthday? May the 5th, for example. What is the probability? 40%, roughly 40%. What if there are 50 people in the room, which is not the case with us right now? What is the probability that two of them share the same birthday? Let's say May the 5th. I just picked May the 5th. Yes, it's almost certain that if we have 50 people in a room, it's almost certain that we have two who share the same birthday. Okay, but the question is different. Part A, explain why f has an inverse that is a function. That's our first question. Can anyone tell us? Say it again. Yes, explain why the function f has an inverse that is a function. By the horizontal line test, because it is 1 to 1. Very good. Okay, here's the next question. Describe in practical terms the meaning and find, okay, the meaning of f inverse of 0.25. What does that mean? So we're not looking at how many people should be in the room for a probability of 40%. We are given the probability or percent, and we want to determine how many people, for that probability, how many people we should have in the room to guarantee 25%. So what will you say? About 15 people. I agree. So f inverse of 0.25 is 15. What about f inverse of 0.5? How many people should we have in the room to be 50% certain, or have the probability of 50% of that two of them share the same birthday? 22, 23, hard to read, but you understand my point. Finally, f inverse of 0.7. What would that be? 29, roughly 30. Not easy to read from this graph. Do we understand how the inverse function works? So the function said, for this number of people, find the probability that two people share the same birthday in the room. Now the inverse function says this. For this probability, I want to be 50% sure, okay, how many people should I have in the room? So the y value becomes the x value. The y value for the original function becomes the x value for the inverse function. Is it clear how this works? Okay, perfect. I don't think I have anything else. Oh yeah, so let's look at how we read from the table. So let's choose a problem. So let's work on a table. Anything you want, any of these. And we just have to read from the table. Same thing as we read from the graph before. Yes, ready? Okay, I would like to look at 57. What do I have to determine first? It says f inverse of g of 10. G of 10. So let's determine from these two tables g of 10. Can anyone give us g of 10? Other than Vinny. I have to be faster than he is. G of 10. Can anyone give us g of 10? Do we all see that? G of 10 is -1. Perfect. Is that clear? Okay, so now we have to determine f inverse of -1. So let's determine f inverse of -1. This is what I want now. I don't want the function at -1. I want the inverse at -1.
Two.
So the inverse of -1 is 2 indeed. Do we understand the mechanism? Okay, very good. I don't think I have anything else. Unless you find something in your homework, please bring it to class. I sent to the copy center a previous test too, so I can give it to you next Monday. Why are these so tired? Okay. Last section of this chapter, 2.8. Okay, 3 things here. Distance formula, midpoint, and circle. One, two, three. Okay, so let's take a look at a line segment between 2 points. This is point A and this is point B. I want to determine the distance. So I'm going to say that A is my first point, so I will denote x1, y1, its coordinates by x1, y1, and point B is the second point, so I'm going to do the same thing. Obviously, this is x1, and obviously this is what? Thank you very much. I forgot to ban you from answering. Good. So we will form a right triangle. And we would like to use the Pythagorean theorem. In this triangle. And you can say, yes, but give me the length of the 2 legs. Well, actually you will. So what is the measure of this leg? X2 minus x1. X2 minus x1 is this distance. In the same way, we will determine the measure of the other leg. Can anyone tell us what the measure is for the other leg? We all agree with that? So then, anyone remembers the Pythagorean theorem? I'm gonna denote the distance between A and B by lowercase d. So the distance AB. This is what we're after. So what is the distance? Squared. By the Pythagorean theorem, the longest side squared equals the sum of the squares of the 2 legs. When I ask my students, please tell me the Pythagorean theorem, they say a squared equals b squared plus c squared. No. Because you haven't told me which one is A, which one is B, which one is C, right? So the longest side squared is always the sum of the squares of the legs. The longest side is the hypotenuse, that's why it's d squared here. And these are the 2 legs. So this will always be the sum of the 2 legs, the measures of the 2 legs squared. And when we take the square root, because which principle is this of taking square roots, we should write plus or minus in front of the square root, right? I will not write it this time. Why? And I'm not changing the rules on you. The reason why I cannot write plus or minus is because we are talking about a what? Right, and the distance cannot be negative. Please do not attempt to simplify this formula. Please do not touch that. We cannot simplify if the radicand, the quantity under the square root, is a sum of terms or a difference of terms. Okay, now there is also what is called, right here in the middle, the midpoint. The midpoint divides the entire segment into 2 equal parts. What segment? The line segment between A and B. This piece and this piece. And the coordinates of the midpoint are the average values of x, comma, the average values of y. Can anyone tell us how to write the average of x1 and x2? How do I write the average of x1 and x2? We had a problem with averages for test grades. We had 6 test grades, if you remember, and we determined the average a long time ago. Exactly. Thank you very much. Easy to remember. The average of x values of the 2 points, A and B, comma, the average of the y values between the 2 points. I would like to practice this. Please give me any ordered pair you want to work with. So let's determine the midpoint and the distance. Any 2 ordered pairs, please. And also put some negative in there. Not all of them, but some negative so we can...
Can you pull it down for a second?
Sure.
Well, I didn't want to copy it. Yeah, thanks.
Is the average.
I know, but I just.
That's fine. Good. Can anyone give us 2 ordered pairs? And throw in some negatives in there. Negative 8, 4. 2, 1. Excellent. Let's find the midpoint. Please add the x values, the x coordinates, I should say. Please add the x coordinates. What do you, negative 6, please divide the answer by 2. That's it. Please add the y values, the y coordinates. 5, and we divide it by 2. So this is the midpoint. That's it. Now we want to find the distance. I'm going to copy the formula. x2 minus x1, everything squared, plus y2 minus y1, everything squared. I'm going to denote the first point by x1, yy, its coordinates by x1, yy, and of course x2, y2. And now carefully I will plug in all this information in the distance formula. My x2 is 2. My x1 is negative 8. My y2 is 1. My y1 is 4. Let's do this together so we don't have to write too much and not too many nested parentheses, etc., etc., etc. Let's do this together, okay? So how much is 2 minus 8? Or minus negative 8? 10. How much is 10 squared? Excellent. Plus 1 minus 4. Negative 3 squared. No. Excellent. So the distance is the square root of 109. Done. Finally, let's talk about the equation of a circle. And that's the last thing in this chapter. Equation of a circle. I'm going to graph something and I'm going to claim it's a circle and you're going to say, of course it's not, and I would have to agree it's not. But just imagine it is a circle. The center of the circle is normally denoted by convention h, comma, k. So this is C, h, comma, k. X is the x h is the x coordinate, k is the y coordinate of the center of the circle. So this is the center. Can anyone tell us what this is? Excellent. And I'm going to call any point on the circle, it doesn't matter where. I'm going to call it A of coordinates x, comma, y. Now, let me know if you agree with my next statement. I claim that the distance between A and C equals R. I should have.
Wait, so in the parentheses, is that H comma K or H
Yes.
1K? Okay.
No, sorry, comma. Thank you. H is the x coordinate, K is the y coordinate. Okay. So here's my statement again. I claim that the distance between A and C, regardless of where A is, it could be here. It could be here. I don't care. It could be here, anywhere. I claim that the distance between A and the center, everywhere on the circle, is equal to the radius. Would you agree?
Yeah.
Of course, it makes sense. That's what circle is all about. Excellent. So I'm going to say that the distance AC equals the radius. But we have a formula that we just looked at for the distance between A and C. So can anyone give us that distance between A and C? And then on the other side, I'm going to write R. X minus H, everything squared. Awesome. Plus Y minus K, everything squared. This is the equation of a circle. There's not the form that you will like, but this is it. We're going to transform it a little bit. Equation of a circle. Now, please square both sides for me and tell me what you get. And that is the form that we like. Both are the same, but can anyone square both sides? If you square the left-hand side, we've done this before when we solved radical equations. So when I square the left-hand side, what do I get? X minus H, everything squared, plus Y minus K, everything squared. And if we square the right-hand side, what do we get? That's it. This is the form that we really like, and we are going to use it. There are 3 types of problems in this section about the circle. 3. Allow me